right now we have our next guest presentation. This is kind of an education-focused presentation. We've got a very significant educational community attached to the world of Autodesk. There's a lot of people out there learning a number of our products. And every so often we do a student reel, and we're always blown away by the type of work that comes out of a lot of these different schools. And one of the schools that we do a lot of work with is Savannah College of Art and Design. So we're going to have this presentation based out of Savannah College of Art and Design. We also have someone from Pendulum Studios, a former student, Alex, who is going to be talking a little bit about the work they do. So guys, why don't you take it away?
Thank you very much. Thank you very much. Come on. Join us down
Everyone,
here.
take a seat. The benches are incredibly comfortable. I keep telling people.
So my name is Louis Cataldi. I'm the chair of the Interactive Design and Game Development program at Savannah College of Art and Design. And today we're going to be talking a little bit about really some of the ways that we go about developing games in classrooms and some of the way we try and focus successful game development with our students. I've brought with me Alex Forsythe. He's currently working at Pendulum Studios, doing a lot of technical animation, technical work in Motion Builder. But he played a very significant role in a game that actually was pretty successful for the students, that was done over a period of 20 weeks. And we're going to be showing you some of that and some of the process that was involved in that, and actually can be played at the SCAD booth, which is down the hallway here a little bit. Autodesk encouraged me a little bit to talk about how I got into being a professor of game development. So I quickly just want to let you guys know I started in the early 90s, like so many people did back then, doing flying logos. I got to do some medical illustration stuff, which was pretty cool. And that led me to move to New York to do commercial work, and I got to do a lot of episodic, long format animation and commercial work of a variety of different kinds, some feature animation. I worked on Craymaster 3, which was an art film, which was pretty cool. Got to do some work on some original TV shows and M&M stuff. I taught at NYU for a couple years, which was a great experience for me and really got me excited about education and opportunity to work with students. And then I ended up joining Blue Sky in 2002. I got to work on robots. I got to rig a lot of these characters as a technical animator, and actually worked on Ice Age 2, The Meltdown, which was very cool. Very happy to have been able to rig the Scrat, which was really an awesome character to pull together and make work for all the crazy things that the animators like to do to that guy. And then I got into games. I got into games in 2005. I went to work for a little bit at DICE, New York City, where we had done some initial prototyping for Battlefield 2, which was really awesome. The original core team was part of the Desert Combat group that built Desert Combat. Those of you who remember, it was a lot of fun and really informed a lot of the gameplay, which is modern competitive multiplayer single first-person shooter stuff, which is very exciting. But that was fairly short-lived, and we opened Chaos Studios in 2005 in Midtown Manhattan. And I joined the studio and started as the art director. We did Frontlines Fuel of War, which shipped in 2008. And we did Homefront, which shipped in 2010. And then I moved back into academia, and I started at SCAD in 2010 as the chair of the Interactive and Game Design program. And now I want to talk a little bit about that program and the opportunities that I've had there, with some of the great students that are actually here today. SCAD has campuses in Savannah, Hong Kong, Atlanta, Lacoste, France, as well as a very robust e-learning program. And the game development program's got about 450 students, and it focuses on a variety of different things. There are about 40 majors in the program, and I think this is one of the great things for our students, is that they can actually take courses across film, they can take courses across graphic design, visual effects, motion media, animation. So not only is it focusing strictly on the game development part of it, but students have a broad range of curriculum that they can draw from if they want to focus on cinematic work or if they want to focus on game writing and so forth. Basically, the interactive and game development program is broken down into a couple of different focuses. It's got 2D and 3D real-time art for characters, environments, and game assets. We certainly focus on game design, systems and mechanics and levels. Very strong technical component that we're trying to bring into it because that's such a very important part of game development these days, as well as production process. And some students choose to focus on how games are actually developed and how they can help influence the production and development. And that includes phase development, planning, scope management, and production methodologies, all of which are such a critical part to actually being able to accomplish a playable game of any kind. So this structure is actually used throughout the curriculum, but by the time students get into the senior year, they start working through a series of studio classes. Studio 1 classes, individual student projects, where they actually are developing assets themselves, different types. They may choose to focus on the game experience, design documentation. They're really not focusing on writing 100 pages of documents that no one will ever read, but really being able to deliver a game experience. And what is it that's fun, and why make this game, and why people are going to enjoy it, and focus not only on the writing, but the visual components that get people excited about a particular type of game. There's a tech art focus, which certainly is a very vital part of anything you see on these show reels, which include particle effects. It includes complex material systems, in-engine terrain work, all kinds of environmental color toning and so forth, and all those things come together. And this is a really important focus because it's one of the hard things that is not very easy to outsource inside of a game studio. So the tech art part of it has been actually very successful for our students, and we encourage a lot of people to become more technical, because that marriage of technical and artistic and design is really valuable to a lot of studios. By the time they get into a Studio 2 class, this is more of a collaborative group project. This is where students come together and they take the individual work that they've done and they combine with other students. So if your focus is design and you've got students whose focus is art and the tech art, they come together and build a group project. And the goal literally is to go through the development cycle like any studio would go through a development cycle, but within a limited scope period. This is only a 10-week class. So a lot of the things that are included in this class are being able to pitch a game, make sure that you've got a solid idea that people are interested in participating in, even at the student level. Quite often the faculty functions as the actual publisher and make sure that people that are pitching games are games that are worth playing and making. There's a full documentation process where we go from not only the technical design and the gameplay design, but also the system mechanics, an art style guide, story beats, character development of all kinds. You know, it's better to fail on paper and fail fast than to fail deep in development when you haven't thought about this stuff. So though we don't encourage people to write hundreds and hundreds of pages of documents, it's really important to know what it is you're trying to do before you jump into it and bring a large group of people together to do it. Finally, they actually go in this Studio 1 class in a pre-production cycle where they might do a beautiful corner, an actual prototype gameplay, and prove that it's actually going to be fun and engaging, all the way to the full production cycle where they bring all the team members together, develop asset lists, get in development for that stuff, do full animation, full rigs for characters, get into whatever engine code that needs to be manipulated in order for someone to be able to be successful in altering a game. Actually go through the full production cycle, all the while managing scope as best possible, making sure that you don't have bloat that is going to slow down process or generate mediocrity. And they actually, for the best part, get into an alpha phase where the game is mostly complete, most of the features are there, now it's time to really polish. By the time they get into their post-production or the finished one, it's time to actually do the polish work. Here's Alex when he was still in college. You can see that he's still a wizard, but the hats, he wears a lot of hats actually. The beta test actually, the beta process actually includes a testing phase where the students actually get together. They do some focus group tests. They bring a lot of other people into it so that they can get the feedback whether the game is fun, whether the mechanics are working, whether the character and the story is being conveyed appropriately. You know, and in the real development, there's quite a bit of polish that can be done from getting feedback both internally and externally. So this is a very valuable piece of feedback, and the goal isn't to redesign the game at that point, but to be able to incorporate those little things that make the experience really worth engaging in. And finally, just the polish of the experience. So everything from improved lighting into a level, or improved mechanics, improved timing, improved cinematics, things that help the story move along, help the player continue to understand how to move through a level, not get stuck, improving collision in a map, improving material performance, making sure that the game isn't so slow that it's a PowerPoint slide instead of an interactive experience. And really, this is an important phase where it's not relevant to change things, but it's important to polish what you've already done and make sure that you get rid of the rough edges. Then finally, in this post-production class, it's also important to learn how to generate some of the marketing materials that are going to get people excited about the work. So they do everything from building websites to learning how to take screenshots, polish screenshots, promote their own games, and really enter into festivals and add value to 20 weeks of work, in essence. By the time Studio 1 and Studio 2 are finished, that's really about 20 weeks of full development on one particular project. As best possible, students try and stick together so that they can polish that experience and deliver a game. And what we're going to show you in a little bit, what Alex is going to talk about, really is the opportunity to bring all these things together to one focused project, and how far a group of about 10 people can bring a project all the way to the end. I think the next slide is actually a small teaser movie that they made for a game called Vestige. I think altogether it's about 16, 20 minutes of gameplay, depending on how you play. It's a first-person puzzle game, and every bit of the art in there is original. It's done in the UDK engine, and they did everything from complex Kismet setup to doing all the art, doing the material work, doing effects, and really trying to deliver an experience. So let's take a look at it, and then after this movie's done, Alex is going to take over and talk a little bit more about it from a student perspective. I want to point out that you can download the game and play it yourselves anytime you want. It's available to everyone. Take it away.
All right, thank you, Louis. Hi, my name's Alex Forsythe, and I was a member of the team that made this game, Vestige. The setup for the course, as you've heard, was pretty simple. As a group of 9 students, we had about 10 weeks to produce a game. Now, 9 students, by the scale of a school project, is a pretty large team. And in addition to the 9 of us who had class together, we also took advantage of some outsourced talent for art and sound. So coordinating all of these people towards a singular goal was by no means a trivial task. On the other hand, 9 people is still a pretty small team, no matter how you slice it. And so because of this, we had a lot of overlap in roles. Everyone had more than one job. And since we were at an art school, everyone was able to contribute to art in some meaningful way, which was good, because we had a lot of art. We'll get back to that in a minute, but first, I'd like to tell you a story about scope. So we all walked into class on this first day, ready to go on what would be the biggest, greatest, final projects of our 4 years in college. And in walks this new professor, this new department chair, fresh from the trenches, brimming with industry experience. And as we're about to throw ourselves headlong into 10 unrestrained weeks of game development, what did he tell us? Well, he told us 2 very important things. For one, he said that a great idea without proper execution was worthless. Secondly, he said in so many words, scope is a killer. Plan to do something you know you can do, and do it well. Well, this was a very salient message for all of us on the team, and we took it to heart. From the beginning, even before this, we made a conscious decision to approach the project with a healthy skepticism that would make us mindful of scope throughout. But despite our best efforts, as is often the case, our project ended up big in ways that we didn't anticipate. Despite making several mid-course corrections to make the best of the time we had, there was still a lot of complexity that we all had to manage. So in the next 10 minutes or so, I'd like to share with you just a few of the ways that we dealt with that complexity and still ended up with something resembling a finished game. First, I'll talk about our ambitious setting and how common knowledge of Maya helped an otherwise disparate art team produce the volume of art assets necessary to make that vision an in-game reality. Next, I'll talk about Scaleform and how it allowed us to meet our user interface goals quickly and fluidly. And I'll conclude by sharing a few things that I've learned since becoming a full-time developer. So, back to early 2011. As I mentioned, our lofty aesthetic vision meant that we had a lot of art to produce. And so that you have some idea of what was on our plates, let me tell you a little bit about the world we were trying to create. Our game is set in a dystopian future Roman Empire, and the game itself takes place in an underground subway system that's been repurposed as a creative execution pit for criminals and enemies of the state. Now, the theme of being underground is something that appealed to the team from the beginning, and we originally had this notion that there would be separate layers of ruins, each representing a different time period in the history of the Empire. We originally envisioned that there would be 3 distinct areas, each with its own unique visual style. Now, luckily, we realized how insane this idea was before we got into production, and we were able to scale back appropriately. But in spite of that, what we committed to delivering was still deceptively complex. There were still a lot of different kinds of areas that we had to deliver. There were big, glamorous promenades for foot traffic. There were subway tunnels, there were maintenance areas, there were, of course, the obligatory ventilation ducts. We had these very low-budget cutscenes, or as we like to call them, stylized cutscenes. And on top of all these areas, we had a healthy assortment of props, posters, decorative decals, hint decals, and effects, not to mention the ever-important placeholder models. So, simply put, it was a lot to deliver in a matter of just a few months. But like I said, we were mindful of scope, and having some idea of what we were up against, we decided to try and play to our strengths as much as possible. Well, we thought, what are our collective strengths? And one good place to look was the curriculum that we had all been through. So in addition to liberal arts courses, we had all gone through some foundational traditional drawing and design courses, followed by a major curriculum that heavily emphasized digital art. Now, these 2 quarters here are the period in question, and they were preceded by a number of courses that directly involved Maya as some official part of the coursework, including working with and for the Unreal Engine. So the fact that we chose to make an Unreal Engine game with a lot of unique art and a prominent story was no accident. We played to our strengths, and it worked out all right for us. Now, one of those important strengths was that, as I said, everyone on the team had experience with Maya. So we were all able to contribute to the art pipeline and pass files around with minimal friction. To give you one example, it was decided amongst our producers and the rest of the team that our game about a subway system needed a train. So it being a fairly prominent prop, Herb, our concept artist, came up with some drawings. Then John, one of our modelers, came up with the meshes. I laid out the UVs and sent everything back to Herb, who painted the textures. And then it all went to Matt, our technical artist, who imported everything into the engine, where Monty, Brian, Andy, or I could move these meshes throughout the level. Now, this was a pretty fluid process, and the people involved at each step of the pipeline varied significantly from asset to asset. Whenever a certain task needed to be done, there was always someone who knew what they were doing well enough to jump onto it and get it done, so that every artist in our little swarm of artists could more or less stick to what he was best suited to. We had similar luck when it came time to implementing some user interface elements. So because we were using UDK, we were able to take advantage of Scaleform for our front-end menu, which you can see here, as well as our HUD. Now, this HUD that we had for Vestige was pretty simple, pretty minimal, but it was based on this earlier HUD that I did for another project, which was an FPS. It was a little beefier, had a lot more features. including in this one particular encounter coming up, I was able to add this little compass here at the last minute just for this one encounter to help it along. So the fact that one schmuck with no prior experience with Scaleform was able to pull all this together in a matter of days should tell you something about how flexible Scaleform can be. Now, if you're not familiar, Scaleform allows you to build user interfaces in Flash and then integrate them with a game engine. And when you're working with Unreal, this integration step is pretty simple and straightforward, whether you're using Unreal Script or working entirely in Kismet. So for this front-end menu, we used Kismet, and we used a combination of Flash animation and in-game effects. So in the Swift movie, we deal with things like user input and display for these buttons and everything. And then in-game, the map runs a matinee sequence that scrolls these little cards around as the user switches through the list of available checkpoints. In order to communicate from the Flash movie to Unreal, all we needed to do was use FS commands. So you call one FS command in ActionScript, it calls a corresponding event in Kismet. And that's really all you need to do to get this communication. So in that example, we used FS commands for things like switching screens and signaling to the Kismet sequence when it should display a different checkpoint and so on. Now, integration is no less straightforward when you're working with Unreal Script. So for every Swift movie that you import into the engine, you have a corresponding movie player class that wraps it. And this class is able to directly call functions in the ActionScript file in the Swift, and the reverse is also possible as well. To give you one very simple example of how this is all hooked up, we have our crosshair animate to show when the player has picked up an item. So these are just the ActionScript functions that perform that animation using the tweening library that is included with Scaleform. Actually, triggering those animations only required one additional line of code in our Pond class. For these on-screen hint tooltips, we used a Kismet node that allowed the level designer to specify a message to be displayed. So when the Kismet action is triggered, it simply passes that message along to the player's HUD, which sends it to the Swift, and we don't have to worry about it after that. The Swift takes care of everything related to display. So for an artist or a designer, one of the great strengths of Scaleform is that it provides this instantly familiar and intuitive authoring environment in Flash. From a programmer's point of view, the strength of Scaleform is that it facilitates and encourages encapsulation. Everything related to the HUD can be developed and tested separately in Flash, and then establishing and maintaining an interface between the UI and the game is then very straightforward. So those things certainly helped us on Vestige, and those are just a few of the things that helped us make the most of that project. After 20 weeks, and just before we all graduated, we called it finished. Now, most of us were not in school anymore. I got a job at Pendulum Studios in San Diego making tools for Maya and Motion Builder. But if there's one thing my meager experience has taught me, it's this. Any project that you work on at the end of the day is an exercise in making the most of limited time. For those of you who are still students, remember that having realistic goals doesn't mean that you're taking the easy road. If you're dedicated, and you have to be, you won't let yourselves off without a challenge. Challenging yourselves in the right way will give you a fighting chance. You'll always have to make compromises on any project, but you can only make so many. So it's very important to make the most of the resources you have available. Use the tools that you have at your disposal to their fullest potential, and always be on the lookout for ways to streamline your workflows and automate tasks. Learn Python. Seriously, learn Python. And when I talk about making the most of the resources around you, I don't just mean software. If you're still in school, don't pass up the opportunity to learn as much as you can from your professors, your classmates, your teammates, the internet, and whoever wanders into the local lecture hall. Spend your time wisely. Give to these people. Put as much as you can into your work, and you'll get as much as you can out of it. Thanks a lot.